So in the first session, we'll be talking about something on the innovations activities so that you get an ideas of which topics can be taken for the purpose of research, etc. Uh, I have shared you the link for AP Info. So today we'll be talking something about AP Info, so how you can use it. And so two things will be mainly. So let me start with the uh, innovations. If you want to do some innovative ideas, and you can note down, and we are going to share you the files also, and do communicate in group as much as possible. So we did talk about epidemiology, then medical research, and today we'll be talking about something on the innovative ideas, right? So, so ideas for innovations and projects in medical and health field. A few people working in the medical college or hospital may think of the uh, medical or hospital, I guess. But the community related, for example, community medicine or physiology department may talk about the health field also. Now, the objective of this session is how to develop new innovative instruments or strategy, etc. And for that, uh, I would wish that all of you should be able to make at some point of time web of position and also uh, effect what will happen. So web of position and web of so what. So disease is produced because of so many factors, and we are asking why. And then what will be the effect if that disease occurs? What will happen? If you prepare that kind of web of position, etc., then probably it will be easier for us to find out where to work if you want to solve the problem. And if you look at this just for the sake of writing, that what could be the innovative measures? So in medical field, you can think of uh, wherever there is a problem, you need to find out the solution. And we'll be talking how we could arrive at certain innovative strategy. In field of health, usually it is community based, but if you look at as a larger value system, each patient coming to the hospital is coming from the community. So from that point of view, the hospital people can think of the health. And in the field also, patient came from the hospital and there are certain problems not solved. So in field of health also, you can think of the medical. Actually, there should be linkages between the health and medical, community and hospital. The strong reference system should be there. And similarly, the project proposals which you write may be related to the hospital or the community. I'm just right now floating one idea is health assurance mission. I have shared the link in the group. So what we are going to do that in the community across the nation, various committee will be taken at a different state, different district, etc. And we'll try to collect the data. Why people become sick? If some strategy is useful, that we can apply across the nation. So uh, in anemia, people know that anemia is a problem to so many people, right? But in that, how to solve the problem? So in anemia, at a village already in a Petla Taluka, I was running a clinic. And I've seen that once patient is given iron folic tablet for 1 or 2 weeks or at the most 1 month, patient will stop taking treatment. So I found out why people do like this. You might be knowing that iron deficiency first leads to problems in the minds, not first anemia. And the moment you start the iron tablet, then immediately you will feel good. Not because of the correction anemia, but correction at the level of the brain. So when we give iron folic for 1 or 2 weeks, patient feels good and they stop taking a treatment. So I found that how to convince them. So we started use of the mirror and we are asking the patient that compare my tongue with your tongue in the mirror. Mirror I was keeping with me. So when they compare the tongue, they know that their tongue is much paler than mine. And so I thought that till your tongue becomes red as me, you should continue the treatment. But now there is okay with me. But what's about the health workers? Because health workers are themselves paler. So how do they compare? So what we did that we applied a mirror and surrounding that we initially uh, applied the natural colors, right? The haldi and then the red of the mirchi and kanku, something like that. But later on we pasted the photographs. So 8 photographs surrounding the mirror and then that becomes anemia detection poster. And now it is in place of more than 1.25 lakh places. It is being used. So very simple tool, which is a multi-purpose, universally applicable, knowledge sharing instrument and treatment tracker. You continue the treatment till you become a red and affordable by all. Mukta means anemia mukta. We want to make the people free from the anemia. And this is why it was used. And this is a diagram in which in center we'll be using the mirror. There is a why anemia occurs, what are the causes of all these things is written over here. And so this anemia detection poster, so many advantages of it are written over here. But this is an example how much it could be useful. So you can see more than 1.25 lakh means minimum 1 CR, 1 crore people must have used by now. So simple innovation can lead to lot of idea. Other thing, when you want to find out something, that there should be a passion behind that. It's not only for the purpose of the publication and only the for the growth. So if you have inner meaning of the life that you would like to increase the peace and happiness among the population, then your the idea or your the philosophy will be much sharpened and you will be able to do much innovation. Other thing is, while we are using statistics, there is a lot of the confrontation will be there. Whether the blood pressure should be normal value 120, 130, 140, 150 at the age of 60 years. Initially, we used to say that 150 is okay. Now we say it has to be 120. Now the 120 figure is right or 130 is right or 150. So what is an ideal? And in practical situation, what we should be accepting and what is the borderline. For this purpose, we need to understand the normal distribution curve, we need to understand the alternative curves, and then need to find out. And when we say the truth, so that has also many dimensions of the truth itself. So when we talk about the alpha error and beta error, that is very important to learn that whenever we say that this is true or not, there's always a probability. There's a likelihood of that what we mean by that, the p-value, alpha error, beta error. So 1 plus 1 is equal to 2, that is a mathematics. And if anything is near to 1, add another thing near to 1 is with near to 2. So when we give an answer based on the p-value, it is a probability. Now, web of position when you want to prepare, you just think of in your mind some disease condition. Take a diabetes, hypertension, scabies, fungal infection, whatever it may be. You ask the first question that why, right? Why? Then you will have answer again ask why. Third, fourth, five. Five time of answer you'll ask the question why. You will see that there will be a web of position. And based on that, you first take a action. Once there is a disease outcome is there, what will the effect in the society on the individuals? That you ask first the so what, then again so what. Five times if you ask, then it will be the web of impact, web of effect. Together, if you make a chart in the center, you need to take a big chart and the drawing sheet, and three or four, 5% can sit together and prepare this. This is your assignment. If you do it, you will really learn a lot, including attributable risk, relative risk, population attributable risk, like that. And once you have a problem on hand, then another question would be, how can I do this? If I am alone not possible, then how can build a team and how do we do this? Then the innovation will come, then the solution will come. And you can challenge your team that how together we can find a solution. I give you another example of innovation. So before that, I thought, let me uh, share one file with you. I just want to share web of position and web of effect. This is how you will be preparing and a very doing in a smaller way, but it will be the bigger one. Let's say in center there is a malaria. Remember and understand there is a malaria. Then you ask question why malaria. Then you will have the answers like infected mosquito bite, low immunity. Then the next question is why infected mosquito bite and why low immunity. Then you will have certain answers like food intake, there is some problem. There may be a problem in the less vitamins and minerals. Then there could be answer like stress leading to low immunity, etc., etc. And then the question is why infected mosquito bite? In that case, patients are not treated properly. Then breeding of mosquitoes are there. Together, it can lead to infected mosquito breeding and infected mosquito bite. You can also write something like people are exposed to outer environment, or you can say that screening of windows were not done, or you can say that the full sleeves uh, were not used. So many things. Reason of infected mosquito bite. Then the third time, first time you ask this question why, second why, and third time you also ask the question to each the reason you ask the uh, for each, and then you for each you will be having the bifurcation in the flowchart itself. One, two, three, four. For each why, each reason, there can be another three, four, five reasons. That also again the four times and then again the five times. There will be a lot of space will be occupied. You will have the web of position, and then you can think of where I can attack. And when you want to attack somewhere, at that time also you need to find out I have so many strategy out of the which strategy I should be using. There also you need to think over. So this is basically how we should think over to solve the problem. Three or four people sit together and prepare this web of position. Then you can take a screenshot and can share in the group. Now, not only this web of causation, now web of effect. What will happen if there is a malaria? In case of malaria, you replace with the typhoid, replace the diabetes, and then find out comparatively which one is more affecting the population. That you can find out. So malaria will be a burden of the healthcare system. The productivity will be reduced. It will lead to anemia. It will uh, reduce the lower the education level. And then when you again ask, this is a so what with malaria. The second thing, if there's a low education, what is the problem? If there's anemia, what is the problem? If there's a burden on healthcare, what is the problem? Like this. So what? Third time also ask so what? Fourth time you ask so what? Fifth time also you ask so what? And then you will find a lot of the events or a lot of the effects of malaria on the society. And you will find that one of the main cause of the malnutrition may be a malaria, which you can remove very easily with help of one herbal medicine which is prepared from अर्क. आंकड़ा बोलते हैं उसको हम गुजराती में, संस्कृत में उसको अर्क बोलते हैं, which is offered to the flowers are offered to the Hanuman ji, right? That can reduce the malaria. So but before we talk on this malaria or diabetes or so many 10,000 disease, what is the effect of that on the population and what are the reasons so that we can break the chain? So this is must for all of you to prepare at least one web of causation along with web of effect. So we continue with our slide. We're talking about another innovation. Uh, uh, I was attending a one meeting at late night in a village. When I was going back to the parking area, I could not see properly at night, and the villagers were comfortable in moving around. So I thought it may be because of vitamin A deficiency. 37 years back, I was affected with night blindness. And at the time, I decided there should be some objective test to find out the night blindness. And so I gave a lot of ideas to other people also. I did myself also. And then we found that vitamin A deficiency it can be detected. And instrument we found out, which is now we call it as a night blindness detection or a bright vision detector. Then we have a nutrition software so that people can be guided easily from where I can take the nutritious diet. Then there is a e-chart. This is to detect the refractory error. Very, very simple way. In a single day, you can find out refractory error of more than 500 school children. So other innovation is combining everything together. Homeopathy, universal healing and Unani, modern medicine, Ayurveda, naturopathy. So best of all, worst of none. The strategy development can also come under the project proposal or innovation research, etc. And the training programs, the health centers, this is current of a program which is going on. Then we have development app which can cater the needs of so many people. You can see a lot of the videos on YouTube. We are also going for the organic farming because of the uh, to prevent the various disorders like cancer, autoimmune disease, etc. There is a prevention kit. We did a lot of research and found out that this kit, if we are going to use, thousands of kits were used for the prevention of the COVID-19, including the nasal application of cow ghee and keeping the granules in the throat. Lots of things were prepared. This step we have on one side the tricolor and also we have the standard on other side. Say this is a tab which will tell about your weight, whether you are underweight, overweight, without the weighing machine. This is MESC tab. These are the various. This is what we are thinking that the we should have one group apart from the government, and this is we are going to build under the banner of Health Assurance Mission. And this symbol says that if you can't do the right, at least one task you can't do the good for the people, at least at the end of the day, one good thought should be done for helping the people. Then we shall move towards, now we'll be talking about few key things in the statistics. Let me start with the scatter diagram. You have two things together in your data, let's say height and weight, or you have income and expenditure, or you say the iron intake and hemoglobin. So if you plot this diagram, you'll have a scatter diagram, and you can, if the line is straight way going on in an oblique 45-degree, then you can say it's a perfect correlation. If a line makes 90-degree or 0-degree, you can say absolutely no correlation. This is something which you can prepare at your level, right? And you can find out the correlation coefficient by finding the R. And there's a very simple formula. And if lies between -1 to +1. If it is -1, absolutely inverse correlation. And +1, very good correlation. Next file, we talk about measures of dispersion. Based on this, central tendency, when you want to find out, let's say, population mean based on a sample mean. If you take so many samples, more and more samples you take, you will be coming closer and closer to the population mean. Central tendency. Now, the mean alone is not sufficient. Why? This diagram shows that in this case, observation are closely spaced, but mean is the same as observation not closely spaced. Here, all the three means are same, but you look at the observation are dispersed differently. And that is why mean alone is not sufficient when describing some population characteristics. And so we need to find out the range, variance, standard deviation, coefficient of variation, and interquartile range. So if you describe everything together, among that most important which we are using is standard deviation. If we use, then we can find out how many dispersion is there. So the dispersion is measured in terms of standard deviation. If I tell you what is your weight, you will be telling in terms of kg. If I say what is the height in terms of centimeter meter. Similarly, in statistics, when we say the standard deviation, it measures the dispersion surrounding the mean. And that's why when we go for the statistics, we take whether it's 1,000 population, 1 lakh or 1 CR, we take as 1. And in probability, we take out of 1. In standard deviation, we say that ±1 standard deviation or ±2 standard deviation that will cover certain area amongst the curve. In terms of percentage, it will be 68%, 95% like that. In terms of probability, we'll say that 0.68, 0.95 like that. So 100 out of that, there is a percentage, is out of 1, it is a probability. but the 100% both are similar. In statistics, we are usually using 1. So range is minimum and maximum. There is a range, largest and smallest. So we need not go for the example. Now standard deviation is most commonly used. The question arises in our mind that why we are not using mean deviation, why we are using standard deviation. Then the answer is that if we go for a mean of the deviation, what will happen? If we go for mean of the deviation, there will be plus and minus sign will be there and they will negate each other. That's why in standard deviation, we are taking a square of the deviations and then divide by the number of the deviations and then we take again a root to find out the standard deviation. Now this chart, if you want to understand properly, then you should try to develop a histogram. Without measuring, without using the histogram yourself in your own data, it will be difficult for you to understand this. So in your Excel file, you try to take a real data of 100 individuals. Either you take a pulse rate, respiratory rate, blinking rate of the eyes, or you can say the hemoglobin level, or any such measurement you try to find out, or the hours of sleep they are taking, and then plot on the x-axis you keep the measurement, and y-axis you take the number of individuals showing that particular measurement, and you take a small interval. Because you take a small interval, you will have the vertical bar diagram, and then you join the central point, and you will get this inverted U-shaped curve. Now we'll pause over here. People say that this is the normal distribution curve. So if just you use for the timing, you forget the word normal, and if you use the usual distribution curve, it becomes very simple. Usually, any parameter you take on the human being or any live being, then usually most of the time you will get this kind of curve. If we think of the height, for example, so most of the people adult having height will be 5 feet, 6 feet, or 4 feet, 6 feet like this. But adult having height 7 feet or 8 feet will be much less, somewhere on the side, much less. While the adults having height smaller, 3 feet, 2 feet, 3 feet, will be still lower. But the maximum people will be around the mean. So we say that mean plus minus one standard deviation will cover 68%. Mean plus minus two standard deviation covers almost 95%. And it is something beyond this, then we can say that usually they do not covered under this curve or they are the outliers. But that doesn't mean that definitely be outside this group. There is some likelihood that they may be in the group. There is a likelihood. So together that makes 5%. And that's why we say that there's a less likelihood, that means less than 5% they belong in the group. We say that usually they don't belong to the group. There is a difference is significant. Right? So now looking at this curve, etc., how do we utilize in case of AP info, right? We'll try to use that. One thing you should remember here that if there is a probability that person belonging to the group is less than 5%, that 95% of the time the person doesn't belong to the group or sample doesn't belong to the group, means likely that is outside the group. Here you should note down that P means probability of the event occurring by chance. P means probability of event occurring by chance. If probability of event occurring by chance is less than 5% in terms of percentage, or P is less than 0.05 in terms of probability, then we say that mostly there is some significant effect why the result is looking like this. And this p value we find mostly in usual cases by finding the z. And z are to be found out by five methods that will be taking next time in various tests of significance. So, for time being, I have sent you the link, download the AP info, and I will show you how it should be utilized. When you download the AP info, you will have these two files, one AP info folder and another is application file. These two files you need to find out from the website, which link I have already given to you. If you fail to do that, I'll be giving you the folder in the uh, Google Drive. Now, when you're this thing, before I start AP Info, let me show you the files in AP Info itself. There's a various subfolders within AP Info. There's the analysis.exe is there, another exe files. Wherever it is written as applications, it is a file which you can execute and do various functions because of that. Here, all, from directly here also you can run that. But we'll be using dashboard. So we'll be uh, utilizing the file which is kept specially to initialize the API info. Here you should be looking at projects. Now in API info, it uses the various languages. When we say a database, there can be so many files, so many tables within that. Suppose if you have a project, you want to control the diabetes and your project on diabetes. Remember this very carefully. In that project, you will have employee, you will have patients, you will have environment, you have doctors, you have various facilities, and you will also have various kind of vegetables available in the market, various of the health functionaries, occupation, different factories will be there, so many things. And in your project, you want to have a details of so many things. But in that, when you create a database, you try to link that database later on. And for that, you need to have a key variable. And key variables should be common to various database files so that you can try to relate when it comes to data analysis. So relational database is very important. Now, out of this, these files are kept in FEInfo software for the purpose of teaching, experimenting, and learning the analysis. You can go through all, but I usually go to the sample database file. And this sample project, among that also, I usually prefer this Oswego file. And Oswego file in this .prg. The .prg means when one project, so many files will be there. So this will access through the analysis thing. But why I show you that whatever you want to do the analysis, you should be able to locate where your file is. If you do not know where your file is located, then very difficult to do the analysis. Looking simple, but this is the most important problem which people face. So let me now start the AP info software. So far so easy. Now, let us say launch AP info 7. Now here we have 6 men. Out of this, we'll be using classic data analysis thing. The create forms and enter data can also be utilized, that you can try it out, but it's not as a part of this course. But if time permits, we can do later on. But this is a must. Everyone should know how to use the data analysis. In that also, we need to learn 6 or 7 commands which are sufficient for preliminary analysis. So far, so simple. And naturally, when you want to do the analysis, first thing you should talk about read the file. So the first command is read the file. Second, once you want to read the file, then next thing will be the analysis part. So I showed you the you go to the projects. In project, you go to the sample, and in sample PRG, you open it up. In this case, we are going to use the Oswego file, which is the file prepared out of the outbreak of a disease. 75 people went for the party, birthday probability maybe, and then doing analysis. So these 75 records are read by the software, and now software is ready to do the analysis. Now they are looking, the software is looking for our command that what do I do for you? We say that give a list. So the record will be shown over here. You can see the record 75. You can see the columns chocolate khayagni, vanilla khayagni, fruit salad like this. And then all 75 individuals will also be seen. Here you can see the data. So this is a list command. It's just like your Excel or browse the thing. Now the next thing will be once you look at the data, before you do the analysis, you need to find out frequency. And if you do the frequency star, instead of star, you can use like this also. You want to see the frequency of age, you will get the frequency of age. Right? Then you want to have frequency of chocolate. How many people took chocolate? That will be there. 27 not taking chocolate, 47 took a chocolate, 36 and 63%. This is a data analysis. But if you don't have much time, you just skip frequency star, and then you will get a frequency of all the data. All the variables are analysis over as well as frequency is concerned. Now, once frequency is there with you, now you want to start comparing the analysis. You want to start tabulating the things. So in that, let's say if we have 10 variables, how many tables will be there? Uh, let's go for that 5. Now the question is, if you have 10 variables and you want to compare 10 variables with the other 10 variables, same 10 variable, how many tables you will have? Let me keep that variable height, then age, then religion, then comes the presence of diabetes, then comes the medicine taking, not taking, then we have the fever history in last 1 month, and then we have type of diet. Suppose you have such a 10 variables, what's the type of oil taken, not taken, sleep, meditation. Now these are 10 variables. So if you say the 10 by 10, you want to do analysis cost tabulation with over here, then tell me the answer that how many tables we can have if we have this 10 by 10 variables in your the dissertation, how many tables you will be able to do it. If possible, write down in the chat how many cross tabulation you will have. I mean over here 2 by 2. Otherwise, there could be so many things. Write the answer. You have 10 by 10, 10 variables. So how many tables with or 2 by 2 variables or even mean versus a characteristic? How many such the possibility will be there? I need answer by at least 3, 4 people if you are attending the lecture. Any answer? I think you are allowed to at least write down in the chat box. Please answer. If you have like this 10 variables with you, 8, then what else? 100, then very good. What else? 800. Any other answer? Because before you start analyzing it, you should think that how many it could be. 10. Okay, the answer is n minus 1 multiplied by, answer will be n square. Write down n into n, right? Minus n, right? Now, when you get this is a formula, that many possibilities you will have divided by 2. So in this case, we have 10. So 10 into 10 is 100. 100 minus n, 100 minus 10. So is equal to 90 divided by 2 is equal to 45. So you have 45 tables with you. You should think about all these 45. You write down A and B in A, B, C, and then you start your analysis. For dissertation also, you should be doing this. Because why I say this 10 by 10 is 100 tables are there. But when you go for height versus height, you are only having a frequency. You can't compare with that in tabular form. So these are the frequencies. So here we can see that this 10 by 10 table, this 10 FFF. That is the frequency you can find. You cannot find out the tables command because diabetes versus diabetes, you can have frequency, you can't compare like that. So that 10 is minus. So out of 100, 10 minus is 90. Now there is a mirror. Whether you compare height with medicine over here or height with medicine over here, both are same. So because of mirror image, half of the part you remove because it is one is the same. So 90 divided with 45. So if you have a cell of 20 variables by 20 variables. So 20 into 20 is the 400, 400 minus 20 is 380 divided by 2, that is 190 possibility we will have. Now, what do you do with this possibility? This is to be done before doing any analysis of any database. So now you think that do you want to compare height and weight? And you write down the weightage over here. Yes, I'm interested in it, but little bit. You write down what. Do you want to relate the religion versus height? Okay. Height versus diabetes? I'm not interested. Height versus medicine? Not interested. Fever versus height? Not interested. Type of diet and height? Yes, it may be possible. I would like to take. Then two. Similarly, height versus oil? Yes. Height versus sleep? Yes, but a little bit, medicine little bit. So you write down like this. And then age versus religion, longevity of life may be one. Diabetes in age, yes, it is a strong related. I write down three like this. So at the end, only you need to fill 45 possibilities. And then based on the number, how many total numbers are there over here on this side, you find out which variable is very important for you and then start your analysis accordingly based on the priority. Any question on this? So now once you have decided this, we'll go for the info again. In Oswego file, we have decided what is to be done. So we, we go for the AP info project file, projects in that sample file. You select sample.trg. In that, so many tables out of that project, you go for the Oswego file and then do the analysis. 75 records are selected. Now, we have seen the read command, we have seen the list command, frequency command. Now let us go for tables command. In tables, you have exposure variable, outcome variable, and for the advanced statistics, you can go for the stratification also. Will not be touching that, but youngsters are supposed to go for that. Also, you should be going for weightage. Also, output to the table, in which table you want to have output. All this thing. But basically, we'll be going for 2 by 2. That whether the milk has any association with illness or not. This you are comparing and then say, okay, and the answer is there. 4 per people took the milk. Out of that, 2 become a sick. No, milk was not taken by 71 people and 44 were having sickness. So here's the 50%, here's 61% sickness out of those who were taken a milk. But then in that, whether this difference is significant or not. So we are looking at the p-value. The p-value over here is 0.6, is much more than 0.05. So we say that it is not significant. Now, we take another variable, tables command. You can ask question in between also. Don't wait for me to, you can unmute yourself and ask the question. Now let's go for vanilla, right? Vanilla versus illness. Now look at the table and you can see here that 79, almost 80% fell sick. Those who were taken, 54 people took a vanilla. You can see 54 here. Out of 43 became ill, so 79.63%. Remember, the raw percent and column percent both are coming. If you look at this vanilla taken and not there, how many fell ill? You call it as a cohort study. But if you go for this table, sickness yes and no, in that how many were exposed to vanilla, that becomes a case control study. Although these are cross-sectional data, but how do you look at the data? So in case control and cost study that I'm just talking about. While if vanilla was not taken, only 14% were sick. Let us see what is about the p-value. P-value is 0.000018. So it's much, much, much lower than 0.05. You can say less than 0.00001. Is a highly significant relation between the vanilla
Yes.
and the illness. So we can say that one of the likelihood as far as the cause is concerned, vanilla could be one of the cause. Similarly, if you look at the means of whenever you are using means command, you first select a variable which is a continuous variable, numerical variable, or which has a value in terms of numbers so that you can find out the mean out of it. Say age or height, weight, from this you can find out mean. You cannot take a means of, let's say, fruit salad. That you cannot take. Means of age. And then cross it by sickness, illness, and see whether there is any difference between age or not. Here you can say that yes, those who are falling ill, their mean age was 39 years. Here you get a variance that is a square of standard deviation. You also get a range that is minimum 3 and maximum 77 years. You also get a percentile, 25th percentile, 75 percentile, median that is a 50th percentile. You also get the mode. This automatically you get it. And whether this difference of 39 years and these 32 years, is this difference of around 6 to 7% is significant or not? You tell me in this group, write down in chat, is the difference of these around 7 years in sick and healthy is significant?
Yeah.
Give answer yes or no, or
Yes,
maybe
it can healthy.
quickly write.
Mm. Yes, sir.
I hope all of you are awake. Yes, significant. Then yes is very quick. Then what else? Yes. Anyone else? Okay, let's say this is statistically significant sample. So answer comes from the p-value. Answer comes from p-value. You let's see where is the p-value. Here they have applied the f status 6 and p-value is 0.2. That means 20% is the chances that this difference has occurred by chance. So P is more than 0.05. So we say that this much difference could have occurred by chance and will not call it as a significant. Although it looks significant, but it is not. While we applying the test of standard of difference to mean, it is not significant. So far, before I wind up, uh, you can use this command when you are at home. Outcome variable is illness. Input variable are cabbage. Only take 0101 which can be converted. Gender. Then outcome variable vanilla. You can take fruit salad. You can take rose. Take 6, 7 variables, chocolates, etc. And say okay. So this is the last table for you. You make it awake. Here, the odds ratio reverse in case of male female. That means males are less affected. Is point to reversal, and it is significant. More females has affected, right? And in case of vanilla, yes, almost 30 times more affected. We can't use the word 30 times, but near 30 times. And PVL is less than 0.00. It is highly significant. Two factors are very much correlated with the illness. Other factors like cabbage, jello, rose, etc., they are there, but they are not affecting much, right? So this is how you can also apply logistic regression analysis. So I stop here sharing the things, and some of you can ask a question so that, and I will share this files with you if not already shared. And next time we'll be talking about, I have just a few ready things, and next session will be on, I will talk a little bit on the outbreak data also, and we'll also talk something about the various type of Z, the standard of difference to proportion, standard of difference to mean, etc. So, any other question? I think at least one question, one person should ask. Then only there is a point in taking a live session. Otherwise, you can have video sessions. Interaction should be there. So we meet again on the Thursday. By that time, most of you must have installed the AP info. Right? Okay. Thank you.